So I've heard some that we need some more practice, and we're struggling a little bit with how to set up a system of linear equations if you're given a scenario. So I really wanted to take this time to give you guys some strategies for when you run into a scenario, what kind of things you should be thinking about, and just some strategies for how to go about. Here's the scenario, how do I get equations out of it, especially a system of equations. So I have just a few of those suggestions here, and then I'm going to walk you through what it looks like to use these suggestions when we're solving. So we'll do this and then two problems examples. So first thing is just when you're reading it, you need to make sense of it. So the best thing to do is just read it multiple times. Even even I still read them multiple times. I don't read a word problem once. You've got to make sense of it. You've got to understand what it's giving you, and then you can kind of go into, okay, what can I do with it? So really, a good way to do it is to read the problem three times, and each time that you read it, you have a specific thing that you're trying to do. So the first time you would read it and make sense of the problem. So like, what's happening? What's it talking about? Like, what are we dealing with? And you can even consider drawing it to make sense of it. I usually start writing or start drawing, just kind of whatever you want, just kind of get something down on the paper to just kind of say, what's going on. You don't have to write something, but sometimes it helps. Then you want to read it again and note any quantities involved. Now, this is the time where you are going to be writing something down. You would go through any quantities involved. Now, quantity, we mean numbers, but it also would describe any sort of quantitative relationship, like this is two times that, or this is one more than that. It's a relationship. Um, Read again and determine the question being asked. So, what are you trying to find? What are the unknowns? And this is where you would like to write your let statements as well, because you'll have your let statements. You'll say, okay, this is what I'm trying to find. You've already written down what you have, and now you're writing down, this is what I don't know, and here's what I need variables for. And you'd write your let statements there. Um, from that, now you've read it and you've got the information down. Now you're trying to make sense of the equation to make an equation using the information that you have. So just some strategies for creating an equation out of that. The first I would say is to say, which of these quantities do I think goes together? Like usually it's through units. Like if you've got like, oh, this was $10, this was $20, this was $15, or there was a total of this many dollars. Those tend to be like, okay, that goes together. This one's all talking about dollars. Just something like that. Which ones do I feel like go together? And that just tends to be a good hint that you're making an equation out of those numbers. The ones that you feel like, oh, these are supposed to be together, you can usually make an equation out of that. That's your hint. So then you want to ask yourself, then, how can I use those ones that I feel like go together? And my let statements that I wrote. So I just wrote some let statements. These are my variables. These are the quantities that I feel like go together. They relate to my let statement somehow. How can I use those then to write an equation? So when you're deciding, like, okay, I've got this info, I've got my let statements, they go together. How am I trying to make an equation with it? Think about what the scenario is. You can draw it, as we said already. You can give yourself random numbers just to kind of make sense of what's happening. So, like, you've got a let statement that says B is the number of whatever. Just be like, well, what if I had five of those? How would I use it to kind of, with the equation? And that can help you make sense of it. Um, However you can, though. I usually find that it makes more sense sometimes when you have a number. You're like, okay, I've got five of these, I got two of these. Um, but then, think about what you did with them. And then you're like, okay, well, I don't actually know that B is five. So I'll just put B where five was. And it kind of helps you write that equation. Another hint that's really good is what type of equation is this going to be? Now, right now, it's like pretty simple because they're all going to be linear equations, right? It's a system of linear equations. So that's a big hint that you know that it's linear, right? Because it's going to be in two forms. It's either going to be standard form, so ax plus by equals c, or slope intercept form, y equals mx plus b. So we'll see this. We'll see this because they're going to be linear equations. So um, we'll see some examples. So let's look at some examples of how to use these strategies. So here's the first example. I'm going to read this 3 times. The first one is to make sense of the problem, ask what it's talking about, what are we dealing with. So a class of 195 students went on a field trip. They took 19 vehicles. Some were cars and some were buses. If each car holds 5 students and each bus holds 25 students, how many buses did they take? So um, we're just kind of making sense of this now. We're on a field trip. We got cars, we got buses. There's amounts of students. Certain, buses and cars hold different amounts, and we're just trying to figure out what's going on there. So just making sense of the problem. I'm going to read it again and note any of the quantities involved. So 195 total students. It says a class of 195 students went on a field trip. 195 total students. It says they took 19 vehicles total. So 19 vehicles total. Each car holds 5 students. Each bus holds 25 students. So 5 students. 5 students per car, 25 students per bus. How many buses did they take? All right. So last thing is to read again, determine the question being asked. 195 students went on a field trip, 19 vehicles, some cars, some buses. Each car holds 5, each bus holds 25. And how many buses did they take? Here's our question. How many buses did they take? That's what I'm trying to figure out. So that's what we're trying to find. What are the unknowns? And let's write some let statements. So the unknowns, of course, in the question, it says how many buses. So that's one of the unknowns. That's kind of an easy let statement. Let B equal the number of buses. The other unknown, it doesn't ask it in the question, but we do know the other unknown is how many cars. We know there's 19 vehicles in total, but we don't know how many cars. We don't know how many buses. So let's just say, let C be the number of cars. From there, we're trying to use this information to set up some equations. In this case, there's 2 variables, so there will be a system of equations. So let's use the information we have. Which of these quantities do we feel like go together? Okay, so usually it's units, right? Usually it's units that we're looking at. So let's look at these. I see 195 total students, 19 vehicles, 5 students per car, 25 students per bus. There's 3 that really stand out to me. This is talking about students, this is talking about students, and this is talking about students. So we have 3 that have a number of students. This one, and this one. That is a really good hint that those are going to be part of one equation. So how can I use variables for my let statements to write an equation? So I'm going to use these guys: number of buses, number of cars, 5 students, 25 students, 195 students. So you can draw the situation if that helps you. You can also give yourself random numbers for the variables. If you can't think about what's going on, it's really nice to just give yourself random numbers for the variables. Like, let me give you an example. Let's say I have 10 buses, 7 cars. That's just random. I literally just made that up. It's not right. I just made it up. So how would I find the total amount of students? Because you're looking at this and it's talking about total amounts of students, right? So if I have 10 buses and 7 cars, well, how would I go about finding the total amount of students? Well, students in cars would be 5 students per car, and then times 7 cars, right? That would give me 35 students in cars. And then I would say, well, how many students in a bus? Well, there's 25 students in a bus, and if there's 10 buses, it's 25 times 10, that's 250. Well, now how would I find a total amount of students? Well, the students in the car plus the students in the buses will give me total students, 285 in this case. Now, like I said, I made these up. Like, this is not a real number, but sometimes it just makes sense to use numbers instead of variables. It just helps to be like, okay, if I had 10 buses, I would do 25 times 10, right? I mean, that makes sense. So now we have to just consider, now that it's set up, um, what if B is not 10, right? I just made that up. So, but I do know that I would do 25 times 10, or 25 times however many buses times the number of buses. Like, I would do the same thing if it were 20 buses, 30 buses, 40 buses, right? I would do 25 times however many buses I have. Now, same thing with cars. I would do 5 students times however many cars I have. So that gives me 5C. So it's just kind of making sense of what's going on here. If you can put numbers with it, you know, you don't have to do this. These are just examples of like ways you can make sense of it. Because now I've got it. And now I know also, I said students in cars plus the students in buses equals the total students. So students in cars is 5C. Students in buses is 25B. Well, I add them together and it gives me the total. Well, what's the total? It's 195. And there's your equation. There's an equation. And it just came out of saying, okay, I think these group together. Okay, how would I find numbers of students if I have buses and cars? Using buses and cars, how do I have the total amount of students? And, you know, I gave myself some numbers. I just tried to make sense of it. And here it is. 5 students for every car. You add that to 25 students for every bus, and it should give you the total amount of students. And then at the end, you know, you can read this like a sentence. You should be able to read it like a math sentence. 5 students for every car plus 25 students for every bus is the total amount of students. Okay, then there's one more. Then there's one more. It is, we remember we need 2 equations since it is a system of equations. The only thing we haven't used yet is this, 19 vehicles total. Well, how do I find total vehicles? I would just add them up, right? So kind of, you could draw the situation or whatever, but ask yourself, how are we going to use this and the let statements? Remember, you've got to be using these to write the equation. So, and the let statement. So how do I use the number of buses and the number of cars to find the total vehicles? Should add them, right? Again, if you want to give yourself a number, well, what if I had 10 buses and 7 cars, right? I'd add them to get the total, right? So you can just say number of buses plus number of cars is 19. And there's your 2 equations. You know, I'm not going to solve them now. This is focused on how do I set them up. But now I have 2 equations. I have a system. You can solve that. And you may also notice that these guys are, as my hint was saying, right? We're doing systems of linear equations. These are 2 equations that are in standard form. So that can be another thing that you kind of hint at, right? They're both in ax plus by equals c. Sorry, that should be a y. Coefficient variable plus coefficient variable equals constant. So that is standard form. You'll run into some that are slope-intercept form too, right? Especially ones that tell you, especially linear ones that tell you this one relates to, it's 5 more than 3 times something else, right? It'll be like, hey, number of buses, right? We could say number of buses is 3 more than double the number of cars. So that's going to end up being in slope-intercept form because 3 more than double. So, okay, double the amount of cars and then 3 more. That's going to be what buses is. So there it is. Y equals mx plus b. It's a line. Just like, because these are linear equations. So it's going to show up in standard form or slope-intercept form because these are linear situations that we're dealing with. So it's something, when you get into different situations where you're writing things for exponentials or whatever, you have to consider, okay, well, if this is an exponential situation, I know what form it is. But in this case, they're going to be lines. So it's either going to be standard or slope intercept. When you run into something like this and it's telling you number of buses is three more than two times the number of cars, the biggest mistake people make is doing this. They will swap that, especially it's like cars is three times number of cars is three times the number of buses or triple the number of buses or whatever. People would be like, um, okay, cars three times, and they'll mix it up. So the number one thing you can do is throw a number in there and just say, okay, well, if there's five cars, then that would mean there are 15 buses. Is that what it works? That's how you can check yourself. Just throw a number in, see if it actually makes sense. Because lots of times people switch these. And then so when you're writing those, that especially the relative ones, the comparison ones, the variables get switched all the time. The best thing to do is just throw a number in, make sure it makes sense and you're right, then you can keep going. So these are just some strategies that you guys have. I know I said I was going to do two, but this video is taking forever, so I'll let you go right there. And hopefully these strategies can help you. If you want to write these down in your notebook as just some examples, some things to like have with you next to it as you try them, go through them and actually, use these as a way to guide yourself as you're trying to figure these out.